Hey everybody, so we are starting on Unit 7 today. Specifically today we're going to be talking about the angles of polygons. So quick little overview, a polygon is just a multi-sided shape, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 plus. 3-sided to 12-sided shapes have specific names: triangle, quadrilateral, pentagon for 5, hexagon for 6. You're going to look at that prefix and it's going to tell you how many sides. All the way up to a dodecagon, which is a 12-sided shape. The thing is, once we get past 12, there are really no more special names, so it's just going to be called an n-gon, where n is the number of sides. So if we have 15, we'll call it a 15-gon. 36, 36-gon, okay? So if you at some point get stuck on which polygon is which, you can look at this little cheat sheet or also Google. A nonagon is 9, because non is 9. So today we're going to be talking about two different theorems. First theorem is the polygon interior angle sum. So the polygon interior angle sum just states that the sum of the interior angle measures of an n-sided convex polygon is n minus 2 times 180. Okay, n is the number of sides. So what that means, angle A, B, C, D, and E all will add up to be 5 minus 2, we have a 5-sided pentagon, times 180, or 540. So our entire pentagon, any pentagon, will have 540 total degrees interior. Okay, so let's look at an example. Find the sum of the measures of the interior angles of a convex heptagon. So a heptagon has 7 sides. So in order to find that measurement, we know that the interior angle theorem states that it is n minus 2 times 180. Okay, n is the number of sides, minus 2 times 180. All right, so we have 5 times 180, or 900 degrees. So any given heptagon will have 900 interior degrees. Okay, so let's take a look and check it. Okay, so here we have a 1, 2, 3, 4, 5, 6, 7-sided shape, a heptagon, and each angle measurement inside is different. Okay, so let's check what that is when we add it together. So we have 128 plus 145, 140, 87, 134, 136, and 130. So when we add all of those together, we get a total interior angle measurement of 900 degrees. That is a heptagon. Okay. So knowing this theorem, we can also find the measure of any missing interior angles as well. Okay, so here we have a quadrilateral, right? 1, 2, 3, 4 sides. First, we want to know how many total degrees make up the interior degree measurement of our quadrilateral. So we say n minus 2 times 180. We have 4 total sides times 180. All right, so that's 2 times 180, or 360 total degrees. Okay, so that's in our quadrilateral. But our question was asking, what are the missing angles? Okay, so here we're going to say, okay, I know that all of my angles added up have to be 360 degrees. So we'll say the measure of angle A plus angle B, angle C, and the measure of angle D has to equal that 360 interior angle measurement. Now we're just going to substitute in the values for each individual measure. So A is 3x, B and C are both 90-degree right angles, so we're just substituting in, and then D is a value of x. So all 4 of these will add together to give us 360 total degrees. Now the next step is just to combine like terms. So 3x plus x is 4x, 90 and 90 is 180, and solve for x. So we're going to subtract 180 from both sides. We get 4x equals 180, and then when we divide by 4, x is a value of 45. Okay, so if x is a value of 45, then I would know that angle A which equals 3x, would have to be 3 times 45, or 135 total degrees. Okay, B and C earlier, again, were 90-degree angles. Angle D is a value of x, which we determined is just 45. So that's how you find the missing angles of an polygon. Okay. So one more example of those. So find the measure of each interior angle of the pentagon. So same exact steps. We're going to first need to find how many total degrees are interior. So 5 minus 2. 3 times 180 is going to give us a total of 540 degrees. Okay, so now we can say all of our angles added up, so H, J, K, L, and M will have to equal 540. So substitute in. H is 2x, J is 142, 2x, L is 3x plus 14, and M is also 3x plus 14. So all of that, add it together. Find the measure of each interior angle. So first we need to solve for x. So we're going to combine our like terms. Okay, so I'm going to do all of my x's in purple. So we have 2 plus 2 is 4, 7, 10, 10x. And then we have 142, 14, which is 156, plus 14 more is 170. Okay, all of that equals 540. So now we just need to solve for x, subtract 170 from both sides. Okay, so 10x divided by 10, x would be 37. So now we just need to take this and plug it in for x. So 3 times 37 plus 14 is 125 degrees. Okay, 2x, or 2 times 37, is 74. We have another 74 degree over here because these are congruent. And then 3x plus 14 again is 125. Okay, so if I was to add all of these together, 125 is 250. 250 plus 142. So 2 times 125. We're just checking to make sure this is correct. Plus 2 times 74 plus 142. We get 250, 148, and 142. That is, in fact, 148 and 142 is 290 plus 250, 540. So we did it right. Okay, and the last example for the interior angle theorem. Okay, the poles for a tent of a regular, they form a regular hexagon. The key thing here is that it is regular. So anytime you have a regular polygon, you are going to have congruent sides and angles. Okay, so if I have a hexagon, I have 6 sides. Okay, if it is regular, then each angle is congruent. So my question is asking for me to find the measure of the angle formed at a corner. So if we're looking at 2 sides, we create this corner right here. So we're just looking for one angle measurement. Right? Now we're going to say, okay, first I need to know how many total degrees are in my hexagon. So n minus 2 times 180, 6 sides, 4 times 180, which is 720. So 720 total degrees in your hexagon, okay? But I have 6 congruent angles. So what I need to do here is say, okay, my total hexagon is 720. I want to divide that by 6, or the number of congruent angles that I have, okay? So in this case, 720 divided by 6 because I have a 6-sided shape. That gives me 6 angles. That makes each angle 120 degrees. Okay. And then last but not least, the polygon exterior angles sum theorem. So with interior angles, it depends on how many sides you have. Exterior angles, doesn't matter how many sides you have. You are always going to have 360 degrees. Okay, so with your exterior angle measurements, it's always going to be 360. So in this last example, find the value of x. Okay, we're going to look at our theorem and say, okay, all of these added together have to equal 360. So sum is 360. Okay, so now just take all of these and add them together. 5x and 2x. And we got 6x minus 5. So I'm just taking each individual exterior angle, adding them together to get that sum of 360. All right, combine like terms. So 2 and 5 is 7, 9, 15, 18. So 18x. And then if we look at our just integers, -5 and -5 is -10. -10 plus 10 is 0, so we don't have to write anything there. Set that equal to 360. Divide both sides by 18, x equals 20. So we were only asked to find the value of x, but if you wanted to know what each individual angle was, you could plug in x to find it. Find the individual exterior angles. All right, one more thing I wanted to go over, I almost forgot. So going back to the interior angle sum theorem, there is an example where it says, find the number of sides, okay, find the number of sides of a regular polygon given an interior angle. Okay, so in this case, if you're given an interior angle measurement of 150 degrees, knowing that you have a regular polygon, all of your angles are congruent, okay? I know that the total interior angle equals n minus 2 times 180, okay? I don't know how many sides I have, though. I know an interior angle is 150, and I know that a regular polygon, all of my sides are equal or congruent, okay? So in this case, if you're given one single angle, it's a regular polygon, then you'll say 150 times n, okay? So the singular interior angle times the total number of sides is actually your total interior degree measurement. Okay, and then you just set that equal to n minus 2 times 180. Okay, so since we're looking for our sides, we just need to get our n isolated. So we have 150n equals, distribute your 180, we get 180n minus 360. Get the n's on the same side. Okay, so we have negative 30n equals negative 360, and then to isolate n, we just divide. So whenever you have a 12-sided polygon or a dodecagon, all of your angles will be 150 degrees, okay? So good luck on your assignment. Let me know if you have any questions. Have a great day.